here. And if I remember right, you talked about how you wanted to talk about some of the things that we just barely covered last time.
Okay, yes. So at the end of Tuesday, we talked about some advanced networking topics. And some of those were NIC teaming we talked about, combining multiple network interface cards to form one virtual larger pipe, 2 switches. And for high speed, if it's a very utilized server or other things, this NIC teaming can be used in different scenarios. Also, we talked about some additional performance metrics that you can use for virtualization. And 2 of those very important ones are single root IO virtualization, or SRIOV, and the virtual machine device queues. So really quickly, I wanted to show you a video of that because this is a real critical design change that happened in virtualization to allow high-speed throughput to virtual environments. And without these type of technologies, you wouldn't have the cloud computing type environments that you have today because they just wouldn't be able to support the throughput, the traffic, okay? And so the 2 is SRIOV. All right, single root IO virtualization. All right, what I'm gonna do is I'm gonna kick this off here and throw some of these away.
Steve and Dave use eToro to trade cryptocurrencies. Steve,
and what I'll do is I'll share my, I'm gonna share my screen.
Hi, I'm Patrick Cooch. I'm the IO virtualization team lead for Intel's Line Access Division. Today I'm going to present a 2-part presentation on Ethernet tech.
Okay, sorry. Getting ahead of myself. Let me share my screen, turn on audio with sharing sound, share screen to, okay. So you should see this now. Let me make it full screen. All right, this technology, single root IO virtualization on the right, and virtual machine device queues, VMDQ and SRIOV. This guy, Patrick Cooch, is part of Intel, and he is going to talk about these technologies, okay? So let's go play this.
My name is Patrick Cooch.
I'm going to jump ahead here.
So by way of a review, let's look at how Ethernet traffic in a traditional virtualized environment works. So an Ethernet packet comes in and an interrupt is fired. You have one core that's assigned to handle all the interrupts for the NIC. That core has to stop what it's doing. So if it was processing a virtual machine, it has to stop what it's doing.
Okay, so here's a little scenario. It looks like a chessboard, but over in the bottom left is this network interface card. This has built-in additional brains or circuitry to allow for queuing, to queue up into queues or lines, into groups, packets that are going to come into a virtual environment. Each one of these people that looks like a pawn on a chessboard is an interrupt. An interrupt is when your processor, it's sent to the is sent from a service to stop what the processor's doing, or in this case, a subsection of the processor called a core, and then stop what it's doing and do something else. And in each of these, you have an interrupt for all of these 8 cores. If this was a enterprise CPU or processor, you could have 8 cores or more. Each of these cores, you can see behind it is running something. One of these guys, look, the green screen is solitaire, I guess. Another one is some gaming. I don't know what these all are. One of them's Google. One's Doom or something in the bottom right. So that blue screen looks like PowerShell.
A blue screen of death.
It does look like a blue screen of death. So that core is hung. It's just sitting there doing nothing. But what happens is the way that it was designed is that core 0 up in the upper top corner or in the middle there comes down, and core 0 is responsible for looking at any traffic that comes into this virtual environment. That's just the way the virtual machine was created, or the virtual machine manager was created. And so it comes in, it looks at the packet, it says, where is this going? To these 8 different VMs that are running on these 8 cores of this processor. And then it's going to do another interrupt to stop the VM that's running whatever it's doing, processing whatever, application, and then it's going to come down, it's going to pass the packet to it, and it's going to take it up to that VM.
And go look at and go get that packet. Next, it has to look at that packet, has to examine it, has to open it up and take a peek at it and see what its destination MAC address is or VLAN tag. And based upon that, they can determine which virtual machine that packet is supposed to go to. And then it has to go interrupt the core that is currently running that target virtual machine. So then that core comes and gets the packet, and it copies it to the memory space of the target virtual machine, and then it continues processing, and then the core that was interrupted to service the packet that came in can continue with its operations until the next interrupt occurs. So as we discussed in the first presentation, the challenge with this type of situation is that you have a single core that's assigned to handle the interrupt for all incoming packets, and it easily gets overloaded when you're trying to do 10 gigabits worth of traffic. And also, every packet that comes in usually results in 2 cores being interrupted, one to service the interrupt on the NIC, and another one to actually manipulate the data and copy it to the virtual machine, thus having some performance.
So the whole point of this is the way that's designed, 2 interrupts, core 0 always gets interrupted for whatever it's doing. If a virtual machine is running there, it keeps getting interrupted to come down and manage the I/O for all the other VMs on that physical server. And in that case, what happens is there becomes a bottleneck, and 10 gigabit of throughput is not possible. Thus, Intel created what's called virtual machine device queues. And what it does is it offloads that sorting from the processor and offloads it onto the NIC card. When packets come into the NIC card, the NIC then creates these queues, these virtual queues, and it queues up the packets into these. And then what happens is, instead of having core 0 always be interrupted, it modifies the code of a virtual machine manager, the actual virtual environment, so that each core is interrupted for its own packets only. So there's only 1 interrupt, not 2. 1 for core 0. Core 0 figures out where it's going to go, send another interrupt to stop the other VM from running, pass that packet over to that VM. So instead of 2 interrupts, it's 1 interrupt, and now they can all run in parallel fashion. Okay. So this is what happens here.
Packets into queues based upon the destination MAC address or VLAN tag, and each queue has its own interrupt, allowing the cores each core to have a different queue assigned to it and a different interrupt, thus spreading the workload across all the cores and improving performance dramatically. VMTQ has a great benefit in doing this. However, with every packet that's received and transmitted, the hypervisor still has to physically copy that data.
All right, somebody's got a hot mic.
Let's see.
Bro.
Okay. Okay, this is actually, I want to do.
Hey, Bart, you can mute him, by the way. You can just right-click him, and there is a mute.
Well, it says ask. Oh, yeah.
I got it.
Okay, so hold on. Let me see here. All right, now the other technology then is SRIOV. Now this SRIOV, what it does is it creates a virtual function driver, and it does the same type of thing, eliminating the bottleneck. And but instead of using interrupts, there's no interrupts at all. Instead of coming in and using the virtual switch, which is up here in the upper right corner for those VMs, it uses what's called direct memory DMA or RDMA, remote direct memory access. So direct memory access, it takes and puts the data that's coming in from the NIC card right into memory for that VM. So there's no interrupt involved. It just, boom, it just pushes it in. And that's what happens with this VMDQ. Sorry, SRIOV. So this is the other technology. It's kind of similar, but a little bit different. Okay. And let's run
And the
this
memory owned by the virtual machine. So there's dedicated queues for these resources, just like we had in VMDQ, and dedicated registers for each one of these virtual functions, and of an actual packet coming in and being copied to the guest OS into the VM. So a packet arrives. Then this packet is sent to our layer 2 sorter switch, and based upon the MAC address or VLAN tag, it is placed into a specific pool. And when it reaches the top of that pool, it is then going to be DMA'd using the descriptors that the driver in the virtual function driver in the VM fills out. It's going to DMA that data. Now, the locations where the driver fills out the descriptor saying where to copy that data to, where to DMA it to, is a virtual address. It's not a physical address, because the virtual machine doesn't necessarily know where it actually resides in physical memory. So the DMA actually hits the chipset, and Intel VTD, which is IO remap.
He kind of cuts himself off there.
So here's an animation showing SRIV in action. A packet comes in, and it's sorted into queues. There's one queue.
So now you see these interrupts are not being affected at all. The technologies that make this work is an improved network interface card with additional circuitry to offload this from the processor. Virtual environments have to have been redesigned architecturally with the software to support this technology, VMDQ or SRIOV. You have to turn it on in the BIOS, called VTD and VTX, and VTD are the two virtualization technology extensions from Intel that are part of the chipset. That's these are the chips, supporting chips around the processor. So the BIOS, the processor, the NIC, the virtual environment, all have to be able to support this technology. It's just like this ecosystem where everybody's working together to do this new technology to reduce the bottleneck and improve IO performance in a virtual environment. So that's kind of the overview of these two technologies. Okay, so that's kind of, hopefully that makes sense in a quick order there. All right, so I'll just turn it back over to Peter then.
All right. So before we move on, anybody got any questions about what we just talked about? Okay. All right. So I didn't really have a good demonstration for server NIC teaming, but I do have the ability to look at packet tracer. Let me share my screen here. And what I have here is I made a little network in packet tracer. There we go. Just do that like that. And Cisco supports what they call it 3 different things depending on what protocol you're using, but it's a link aggregation or port aggregation, or ether channel. It's basically all the same thing, just different protocol. And Packet Tracer has the ability, you can put a server with multiple NICs on it, but you can't configure any of these link aggregations on that server at all. So I can demonstrate how you can do multiple lines going into a switch with the server, but it actually will not do real link aggregation. Now, that being said, the switches actually will do link aggregation, and so we'll look at how to configure each of those in just a minute. But let's take a look at the different the setup we have here. So we've got 3 switches, 2960 switches, and link aggregation or port channel or Ethernet channel or NIC teaming. It's all a layer 2 technology. So you don't need routers or anything. So you notice we don't have any routers in here, just it's all switches. Also, if you notice, we've got a bunch that are orange here, all these links that I've got. So I've got 4 links going here, 4 links going here, and 4 links going here. Some of them are orange because of the spanning tree protocol. We saw that a couple of weeks back. I put these little ellipses around here just to show that these are all linked together, or at least this is what we're trying to link together, the devices. Then I have some normal computers here so we can simulate some traffic. And yeah, and then each one of these links here, we're going to do a different protocol just to demonstrate the different configurations and what it looks like. Pretty much all the same config commands, it's just a little different mode, I guess you could say. So the 3 different types that Cisco supports, at least here in Packet Tracer, are LACP, PAGP, and Ether channel. So LACP is your industry standard. All of the servers should be able to talk LACP, as well as most other networking equipment. It should support LACP. Higher end networking equipment, lower end stuff may not do port channels at all. PAGP, on the other hand, is similar to LACP, except it's a Cisco proprietary protocol. So you have to use Cisco equipment on both ends in order to talk PAGP. And obviously, Cisco feels that they have a better protocol than the industry standard. So you should, if you've got Cisco equipment, then you should use PAGP. Otherwise, if you got a mix, then you have to use LACP or Ether channel. Ether channel is basically the same thing as LACP, except without the protocol. It's all manually put in. So, but it's fairly easy to configure. So you can use this as well if your end device or other device that you've got that's not a Cisco brand possibly could use just straight Ether channel instead of LACP. So, but let's I think that's pretty much it as far as the different things we were going to talk about as far as the overviews. I feel like I'm just jumping ahead, but nope. Let's get into CLI. Let's see what it looks like on one of these switches. So let me show you what we've got running. I've got a basic config on here. Got a couple of VLANs. Well, port 10 and port 11, which are these computers, are on VLAN 10 and VLAN 11. And I just arbitrarily chose those VLAN numbers. There's no reason for it. These 2 ports going to switch 2 are on the gigabit Ethernet ports. And then these 4, I'll have to check. I want to say put them at the beginning. If you want to check what's up and what's down. Nope, I put them at the end. So this show interface status command will actually show you all the interfaces on your switch, and this works for switches but not the routers. So gigabit 1 and 2 are connected, and 21 through 24 are all connected. That's these here. Now when you do these port channel or link aggregation type commands, you have to use ports that are of the same speed. So you can't mix gigabit with fast Ethernet or vice versa. You have to use, so if you're going to port channel 2 gigabit ports, you got to use only gigabit. You can't use fast Ethernet with them. And fast Ethernet has to go with fast Ethernet. You can't put gigabit with it.
So is that what you're doing there on the one between switch 2 and switch 1? You got the 2 gigabit ports right there?
Correct. Yeah, there's
Aggregated?
only 2 gigs on there, so that's what these are here, these links. So, and then the others are connected to fast Ethernet ports because this switch only has 2 gigabits and the rest of them are all fast Ethernet. So. And then, so let's do this LACP one first. So what you do is you go into the configuration mode, and you get into the actual interfaces, and you want to select, well, you want to do the same commands on multiple interfaces. So Cisco gives you a interface, and then they have a special command that you can do for multiple interfaces called range. So you can do interface range, and then GI 0/1 and then a -2, and that will do both interfaces with one command. So in this case, the command to use to create a port channel would be channel group, and then you have to use a number, and I'm not sure what the 1 through 6 in a 2960 switch. It depends on the model of switch you have as how many channel groups you can have. But on the 2960, you can do 6, it looks like. So in this case, we're going to do 1, and then mode. And then now you do a question mark after the mode, and it will tell you all the different modes it can do. So we have LACP, PAGP, or Ether channel. And with LACP, you've got to have one side be the active and one side be the passive. So in this case, we're going to make this the active. And so the word active is what you have to type in here. Active. And then after that, there's nothing. It's just a carriage return. That's what CR means. And then so now it bounces the ports. They already went down and went up. And also, if you look, show run at the very end of the config. All right, where'd it go? Now it's going to be a liar out of me. Oh, here it is at the top of the config. You now have a new interface in here called interface port channel 1. So it creates that when you assign this channel group 1 mode active. So basically that is the virtual configuration for both of these 2 ports. So if I want to make both VLANs go across this link, both VLAN 10 and VLAN 11, I have to make this into a trunk port. So to do that, you do interface port channel 1, and then switch port mode trunk. And so that will then create a trunk link between this switch and the next switch over. Now, of course, it's not active at the moment because I haven't configured anything on the next switch over. So we will jump into the next switch. Let me be good here and save my config. And we'll jump over to the next switch. Okay. So now we'll do the same thing. Show interface status just to show you that we have this one, we have gigabit 1 and 2 connected. And we have 2 computers on 10 and 11. And then these 4 are up here on 3, 4, and 6. That's what these are connected to. So, and you don't have to put them consecutive. I just did that because it makes the configuration easier. But you could have them anywhere on the switch. You could have port 1, port 8, port 16, port 10, all lagged together. That's another term for this link aggregation, lag. So, but you could have multiple ports like that, just jumbled all over the switch if you like. But in my case, I've just put them all together consecutively. It makes it easier. So anyway, so go config T, interface, range, GI 0/1 through 2. And then we're going to do channel group and 1. I don't think this number has to be the same on both ends, but it just makes it a lot easier to manage when you if you have one switch with port channel 1 and then another switch with port channel 2, you might get confused. So just keep it the same on both ends if you possibly can. So channel group 1 and mode. Now this one, because we're going to do we're doing LACP on the other end, we can't make this one active because then it won't work. One side has to be passive. So we're going to do passive on this one, and that's enable LACP if the other device is detected. So passive, and boom, it bounces the interfaces yet again, and we do a show run, we see our interface port channel 1 is now there. So we want to configure that for a trunk as well. So whoops. Port channel 1. Switch port trunk. So you don't actually put the trunk commands on the actual interfaces. You do that on the port channel, the virtual interfaces. And you can see that it is gone down and it's negotiating its port channel, and it brought it up. And now both ends are orange because of spanning tree. So it's going through its spanning tree protocol to see what can be brought up and what cannot be. And it should go green here in just a minute.
And is best practice to leave spanning tree on when you do these link aggregation, so you don't make a mistake and do a bridging loop, or you know what I mean?
Yes. And if you go by Cisco best practice, they say never to turn spanning tree off. Just leave it on all the time. So, and so now if you do a show, I think it's ether channel. We'll show ether channel. It'll show you that we have a group 1 ether channel. It's a layer 2. There is a layer 3 ether channel available, but not for these switches. These switches only talk on layer 2. And I'm not sure if it's named differently or not. I've never used it. So we have 2 ports in the channel. We have a maximum of 16. We have 1 port channel, and you can have a maximum of 16 port channels total. And then the protocol we're using is LACP. So that side is now configured. So
Now,
let's.
is that confusing to people when you do the command show ether channel? But ether channel is a specific way to do link aggregation, but we're using actually another one called LACP, but the command you used was show ether channel.
Yep. So ether channel is the older specification, I guess you could say. And so the command show ether channel will show you everything.
Yeah.
No matter how you've got it configured. So it'll do all the different protocols.
Yeah. So if you were confused why we said show ether channel and we're not using ether channel, we're using LACP, right? Are we using LACP or PAGP?
This one's LACP. So
Yeah, LACP,
we've got
yeah.
it highlighted here.
Just want to verify.
We're going to
Yeah,
do
so,
PAGP
yeah.
next.
Okay.
So, yeah, I guess speaking of PAGP, let's get that configured. So let's do a show interface status just so I remember where my, which ones I've got connected here. It looks like 3 through 6. And this always trips me up. Doesn't seem like ports 3 through 6 would be 4 ports, but it is, because you count 3, 4, 5, and 6. To me, you subtract 3 minus 6 and you get 3. No, it's actually 4 ports. So anyways, that's just me. So you config T, and then interface FA. Let's do a range. Sorry. Otherwise, I'm typing 4 separate ports. FA 0/3 through 6. And now I've selected all 4 ports in one command. And then we do channel group. And then we've already used 1, so we can't use 1, so we're going to use 2 now. And then mode. And then because we're doing PAGP, we have the choices of auto for PAGP or desirable for PAGP. So this one, you got to have, it's like active and passive, but I guess Cisco couldn't use active and passive, so they used auto and desirable instead. So in this case, we're going to do auto. And there we go. We got all those went down and went back up. And if we look in our config, we now have 2 port channels. Port channel 1 is interface switch mode trunk. And then we have another interface port channel 2. So let's config that. Interface port channel 2. Switch port. By the way, switch port mode trunk. If you guys didn't believe me when I do the shortening there. Switch port mode trunk. And that's that for that. Now, I'm curious. Show ether channel. Will it show me if it's up or not? No, it doesn't show me if it's up. It might be a different show interface. Channel 2. Yeah, it doesn't show me. Another quirk of packet tracer. So if you notice that it's spanning tree is really complaining. Your spanning tree block PVID up and down blocking VLAN 1. Yeah, it's not happy. So let's make it happy. Config T. And okay, so if you're in configuration mode, and if you try to do a show command like show interface, it won't let you. Yeah. So the way to get around that, you can either type in exit and go into regular mode, or you can go use the word do, and then you can do show interface status, and it will actually do the command like you wanted it to. So just a little tidbit. So here we got 1 through 6 are connected. So, I wonder why that is. Oh, I've got 2 on the server. That's why. Okay. All right. So let's do, I think it's 3 through 6 again, if I remember right. Show interface range, or interface range, FA 0/3 through 6, and then channel. Yeah, there we go. Mode. All right, channel group 2, then mode, and then we want to do desirable for PAG-P here. All right, and that bounces everything around again. Let's just trust me here. Oh, let me do it. Okay, so exit. Do the show run again just to make sure. Yeah, interface port channel 2, it's there. All right. Interface port channel 2. Okay. Maybe do an exit in order to get into this. And then we're going to do switch port, mode, trunk. And now we've trunked this link. Show ether channel. So now we've got a PAG-P ether channel. It's up and running. Everything's happy. This one's still orange, but it's going to be orange no matter what because of spanning tree. But we'll configure that for ether channel. And then it'll demonstrate what happens if you take out those links and watch spanning tree go to work. So let's see here.
So what's faster, fast Ethernet or gigabit Ethernet?
You're asking me?
No. Let's see.
Who's
Nemo?
asleep?
Nemo, what's faster, fast Ethernet or gigabit?
I guess.
Yeah, just guess. It doesn't matter.
Gigabit question mark.
Yeah, gigabit is faster. Yeah.
Yay!
Yeah, nice job. Because it's kind of a misnomer that we've talked about a little bit, but when they had 10 megabit, which is 10 million bits per second, okay, then they went to 100 million bits per second, and that was fast, and so they named it fast Ethernet. But nowadays there's 1 gigabit, which is 1 billion, not 1 million, 1 billion packets or bits per second. And then there's 10 gigabit, 40 gigabit, 100 gigabit. So they should have never named 100 megabit per second fast Ethernet, but they did. And now the name's stuck. And now you've got this fast Ethernet and gigabit, but just know fast Ethernet equals 100 megabit per second. Yeah.
Yeah, it seems like all of these big tech companies make that kind of mistake early on. Like Microsoft, they came out with Windows NT. The NT stood for new technology. And that was 25 years ago. Not very new.
No. Then they went to, thankfully, a numbering scheme, Windows 2003, 2008. And even then, it wasn't actually the year that it shipped. But anyway, we won't get into that. But it was supposed to be, this came out in 2008, 2012, this came out in 2012, you know what I mean? but 'cause you're right. They say new technology, but now it's very old technology. Yeah.
Okay, so back on track. So we're going to do an ether channel now on this last link here. And so because we've done group 1 and group 2, I'm going to make this group 3. Even though on the first switch we will only have group 1 configured, I'm going to make it group 3 because we have 3 links. And then we do a mode, and then in this case, if we're doing just ether channel, there's only one option, and that's on. So you just type the word on, and that brings that up and down. And look at our config. Yep, we now have a port channel 2 and a port channel 3. Interface port channel 3. We'll do switch port mode trunk. Maybe. There it goes. All right. And we'll do a right to none on that one. We're done with that for right now. Let's jump into this first switch again and configure this last link. And interface status. I want to say these, yeah, I did a 21 through 24 on these. So interface. So I shortened the R to range, and then so basically I just did it as small as I possibly could, and then yeah, that's right. Channel. I forgot the command there for a second. Channel. Come on, you can do it. Channel.
And
group.
these numbers that he throws in, I mean, when you say why is it interface range, fast Ethernet 0, 21 through 24, well, it's simply because those were the actual ports that he connected these together. And that's why he's choosing those. I mean, you could choose ports and put an ether channel, but if nothing's connected to them, then obviously it's not going to work.
All right, what did I do wrong? It says cannot bundle. F80/23 is not compatible with 21. DTP mode of that is strange. Okay. Well, it took it all. To a show ether channel. All right, it's on. Okay. So here we have group 1, which has no protocol. Group 3, which has LACP, which is strange. Because port channel 1 is supposed to be LACP, and group 3, so maybe I accidentally typed group 1.
So we're talking 3 different ether channel configurations, LACP or PAGP or ether channel, and you've got 3 groups, right, that you show, right, when you do a show ether channel.
Yep.
And but you can only have one active at a time, or can you have them all active at a time?
You can have them all active at a time. This particular case, these links are down because of spanning tree, because we have a loop. So if I were to say go into this switch and disable, say these 4 here.
Oh, are you running both LACP, PAGP, and ether channel on the 3 separate links between the 3 switches?
You got it. Just to demonstrate that you can do it 3 different ways.
Okay, so you're literally running 3 different technologies
Right.
on these different
one
groups of links to show how it's configured, but
Correct.
all 3 could be running together, but
You don't
you
necessarily
could
need to do
not
it that
you
way.
could not put LACP and say PAGP on the same group of
You got to pick one.
yeah, you've only got to pick one. It's gonna error on you, right?
Right.
Yeah.
Yeah. So and then it's got to be the same on both ends. You can't do PAGP on one end and LACP on the other end. It won't work. You got to use the same on both ends. So yeah, but in a network, you can have multiple. You can have some that are LACP, and you can have some that are PAGP, or some that are just manually configured. And that's what I was trying to show here. However, of course, as good network engineers and IT people, you want to homogenize things as much as you possibly can, because it makes it easier to manage. So you use like the same manufacturer of devices as much as you possibly can, and use the same commands, same protocols as much as you possibly can, just so that it's easier to manage. But in reality, you're the engineer. You can make it 3 different ways if you like. So, um, so anyway, so yeah, we do. I'm not sure which ports those are. Come on, there's okay. All right, the 1 through or 3 through 6. Interface range FA0/3 through 6, and we do a shutdown. I've just brought this one link down, and so if we give spanning tree just a minute here, it will bring these ports up. I press the fast forward time just a minute. There it goes. Come on, you can do it. I'm not sure why these are still orange, but maybe I misconfigured something. So if you do a no shut, it brings them all back up. Up. And it will automatically bring these up. Fast forward in time, all back to green.
Yeah, there's 2 technologies going on here. One is he's linked these together, whether it's in a group of 4, or a group of 2, and then they're aggregated together and seen as one big pipe, but then they're physically connected into 4 ports, and spanning tree then looks at that and goes, you've got 4 links coming in, so one's got to override the other. And the ether channel goes in, and then spanning tree must verify that it's an ether channel. Otherwise, it's going to stop it. Now it looks like in the bottom here that's ether channel. It's trying to go green, and then going back orange on the bottom there. You see that?
Yeah.
Peter? 2 of them at least.
Yep. So normally, if this was correct, I think I've got something misconfigured, probably on this switch. But if I did this correctly, this side would be green, and this side would be orange. The rest of it would be green, just because of spanning tree. But in this case, it looks like I've got something misconfigured, and it's the whole thing is down. So. To troubleshoot that, you can take a look. So we've got 3 through 6 are desirable. Uh-oh. I disconnected it. Must be 4. Okay, so these are all desirable. And then these are, okay, so fast Ethernet. That's the commands. Channel group 3 mode on. 21, 23, 23, 24. This one should be also be the same. Yeah, I'm not sure what the problem is. It's all configured correctly. Oh, anywho, also something else I wanted to show you guys, since I knew this was not going to take this very long to go through these 3 different types. I wanted to show you. We were talking about Linux the other day, and I wanted to show you some things. It seems like all the cool tools for networking people are on Linux. So let me bring over my Linux desktop, and I'll show you some of the tools I use in everyday management. So this is my ASRU Connection Manager. It is a tool that I use for SSH as well as RDP. And in here, I have configured all of the different devices that I need to get into, different switches, routers, Palo Alto firewalls in here. And so, say for example, I wanted to take a look at the switch in the Abbey. I just double click it, and it will automatically SSH into that switch. Gives me a warning, say, "Hey, you're a bad guy. If you're not here legally, then don't go here. Go away." But anyways, so and then it will automatically put in the username and password for the that switch, and now I am able to do the normal things just like we do in Packet Tracer. So, and then to get out, we just click exit, and it will bring me back to the normal page. So I've got that set up for every switch that's on campus. Also, if I need to, say for example, this particular group, I like to keep an eye on. So sometimes in the morning, I will just click on connect to the entire folder, and it will then log me in to every single switch that I've got configured in that one folder. So now all of them are in here under different tabs. And if you notice, I have different colors of backgrounds. For example, well, all these are orange, but this one's red. This is my own designation that I made. The red background means that something on this switch is critical to the university's running. So if I go in here and I mess something up, that's going to affect a lot of people. Whereas orange, if I go in and screw something up, then it's only going to mess a few people up. It's not going to be critical to the university. So it's just a reminder for me to be really careful with things that are red. So I'm going to click exit. All these just to show you. So anyways, it launched 13 of them all at once. These are all the different switches around campus. This happens to be all the Cisco switches that we have on campus. In addition to that, if I want to do something locally on on the Linux computer in the command line, you just click local shell, and now I've got a normal command prompt. So if there's some sort of Linux command I need to do, such as an ls command, it will do normal Linux as well. You just like exit and it'll go away. It's also got features for Wake on LAN, which I don't really use much, different preferences, and that type of connection. Also, in addition to that, I use this for getting into SSHing into our Linux servers on campus, as well as a few Windows RDP sessions. So I could do, say, this one. Well, of course, I picked the one where it didn't, oh, there it goes. So now I've got a Windows RDP session in Linux in my connection manager. So I can do the things I need to do through a GUI on the server, all from this one location. So it's very handy. It logs me in automatically with whatever user I decide to use. And then I can disconnect. You don't want to shut it down. Otherwise you'll end up breaking something. So that's my connection manager. I use this a lot. It's a very, very, very handy tool for me.
And it's called, is it called Asbro or?
Yeah. After doing a lot of searching around for the internet. So in Windows, there's a similar product called Secure CRT, but it costs money. And so doing some searching around, I found this one in Linux for Ubuntu called Asbro Connection Manager, and it works fabulously, and it's free. And then another open source.
Hey, can I ask a quick question?
Yeah, sure.
So, if you're trying to use a private key or whatnot, does that software support it, or is there any,
Sure.
like, do you have to save the profile for it?
Yeah. Here, I'll show you. I've got one. I think it still works. As a test, I set up a AWS instance. Yep, there it is. So AWS needs a key, a certificate, in order to work. So I've set this up, and now I'm working on a server out on the internet someplace from Amazon, and it just instantly logged me in. So if you go to edit connection in here, this gives you the preferences for it. This one is running over a VPN, so it's got a local address, 192.168. But in here,
So is this Amazon's Linux distro?
yeah,
So you've got this, but you're running a 192.168, which is a private address, but it's on the internet somewhere?
well, we have a nailed up VPN connection to Amazon.
Oh.
Yeah, using their VPC. So, and we do that for so that engineering students can use, I want to say it's AutoCAD on AWS, and the licensing comes back into our license server here on campus. So they use the VPN server to get to the license server. So as a test, we set up this instance out on the internet, out on Amazon AWS, so that we make sure that the VPN's running.
So you have a scenario where you have a hybrid cloud where you got your private data center or private cloud is here on campus, and then you go through a VPN, which extends your network and VLANs to Amazon Web Services.
Right.
Okay.
And I'm trying to find a spot where I specified what.
It was on the connection detail
Oh, it's here?
on the bottom.
Oh, my private key. Yep.
Yep.
So I've got a private key file here in my documents, and so I've specified it here, and then I'm logged in as EC2 user, which is whatever Amazon AWS says it should be. We just went by their documentation for it. So yes, in answer to your question, yes, I can send just a normal username and password, or I can specify a key file as well. I really, really like this connection manager. It's pretty slick.
Great, thank you.
The other thing I wanted to show you guys is my monitoring software for networks. So this is Libra Nms, And again, it is an open source software. This is actually a server that you have to set up, and then it presents a web page to you. So the nice thing about this is that I can then log into this with my phone or a laptop anywhere on campus, and I can see what's going on at any one time, anytime I want. In here is every device on campus that I keep track of. In this case, I've got network devices, I've got different VPNs we do to different places. The bane of my existence are these clocks that we have around campus that they go up and down all the time. We have,
I was gonna say, green is good, red is bad, and you've got 3 clocks that show they're down.
Yep, 3 clocks on campus that are down at the moment, but give them an hour and they'll be back up. The software that was written to manage these clocks is not very good, and it causes them to go off the network. And so, yeah, it's just I can't wait to replace them.
Okay, so what about the host, this old wireless system? You got one red. What happens when you drill down on that there? What do you see?
Okay, so this is Sebula, room 202. That's the access point. It's a ruckus access point, and it's been down for 135 days. So it's been a while. We've been waiting on a new AP for it. This is on our old wireless system, so we have to get a new one. And so to give you a better idea of what a good one will look like, I'll just click on one of these. This one's in Parsons. So it will give you graphs on traffic that's going through the access point. It will give you graphs on what the processor usage is for it, how much memory it's using, as well as other goodies. And this is not only for just daily, but also weekly, monthly, and yearly usage. Different processor, memory, the ports that are on it. So in this case, there's Wi-Fi 0, Wi-Fi 1, wireless LAN 1, 2, and then 32, as well as different VLANs that are on it. And then you can also do different wireless statistics, including client count, the utilization statistics for that access point, noise floor, and errors. Excuse me. So yeah, there's all kinds of different things on here. What I really like to see is the actual network switches that we have. It tells you what kind it is, a Cisco or a Dell, what version of the software it's running, its uptime, how long it's been on before it's been rebooted. You can see our core switch has been up about 8 months now. Those you don't generally reboot very often, so it's probably good. But the other ones, they tell you what model of switch and the firmware version. And then if you click actually on the switch itself, it gives you the same type of traffic information as well as processor, memory.
80 days. Was that because we had a power outage? Was that what that happened?
Yeah, we had a power outage 80 days ago, so most of them
I'll
are
show
80
they've
days.
all been running for 80 days. I'm like, there's something there with that. Yes.
Yeah, and so yeah, so each of these has all of the different information that you've got. Neighbor information of what other switch is connected to and what port it's connected to and what that graph looks like. So there's all kinds of cool information in this, but in addition to that, you can create your own dashboards. So I have created several in here that show you different, this is the actual internet traffic that we have total for the university. And if it's really interesting because it shows, it kind of drops off at 4 to 7 o'clock in the morning. So if you look at, say, a 2-week graph, you can tell when everybody goes to bed and they don't use the internet anymore. So Yeah.
Their highest was 800, a little over 800 or 8.5.
Yeah, here 937.55 in this 2 weeks period is the max it saw.
So you almost
or
hit a
recently
gig
did.
of throughput.
Yep, almost. Our highest I've ever seen is 1300. And then as a test, because we just purchased a 2 gig line, just as a test, we were able to push 1700 megs through it. So other dashboards I've got, the different wireless. So this is all of Parsons, their wireless access points and the utilization of each. So because people were complaining, especially in Parsons, that they weren't able to get on at the beginning of the year, I noticed that there was a lot of utilization on this, and so I had to go in and do some configuring of each of the access points to get them to not interfere with each other, as well as to balance out the utilization on each. And it seems to have gotten a lot better on them. This one looks like it might be a little bit high, but not too bad. Max is 84%. So, but
now if you're getting to 100% on any one of these wireless access points,
then
then
they're not
if
able to
it's
get on.
100% or reaches 100%, you're going to see slowness or drop connections and so forth.
Correct. Yep. Yep. And unfortunately, people will want to do Zoom over wireless. And when that happens, you have lots of people that want to do Zoom all at once over wireless. And that just, it will drop their connection and they won't be able to see the meeting, and people, their voice will drop out and things like that. So yeah, it's hard, especially in high density environment like Parsons, but I think I've got it pretty well balanced now.
Well, if Zoom takes about what, more 4 meg per person, plus you've got if you share, like if you stream something, like show a video or something, then it can jump up to 10 or more.
Yeah. Yep, it does.
Per person. It does each dorm room have a wired connection to the internet?
Yes. Every dorm room has at least one wired connection. Some dorm rooms have up to 3.
Oh.
So
they definitely could just plug in. Is that what you recommend? They just plug in?
That's what we absolutely recommend. Yep. And if their computer doesn't have a network jack on it, we recommend buying a dongle, just because, yeah, the wired connection is going to be the most reliable on campus, the way to go. Wireless is mainly used, it's designed to be used for consuming content rather than connecting to a Zoom session. So like doing Netflix or YouTube or posting something to Instagram, that type of thing, that's perfectly fine for wireless. But you try putting Zoom, that's something low latency on there, and yeah, it
Does everyone know what a dongle is? That's actually the technical term. A dongle.
Yeah,
that is?
That's actually a real term.
That's a real term, okay? It's one of these, okay?
There you go.
So you connect in, and it could be a connection into HDMI or USB, and on the other end, in this case, this one's for a monitor, okay? But you have these for USB to a network port, and so it's just a little conversion, a technology conversion. It's technically called a dongle. So, and they're kind of expensive, especially for Mac. Well, everything for Mac is expensive, but for Apple. But if you have a MacBook Pro or something, then you can buy one of those conversion utilities from your USB, which is either USB 3 or whatever, to then sometimes they have a combo. It can come out HDMI, or it can come out Ethernet or so forth.
So I think we're about out of time. Yep, pretty close. And so yeah, I just was going to stop sharing here.
And Libra Nms is also open source software as well?
Yep. Like I said, all the cool tools are all open source for networking stuff. So like I'm working on network automation at the moment, and that's all Python based, open source. Any questions from anybody while we're got a minute? All right, well, in that case, we will see you guys on Tuesday.
Right.
Bye.
Are you using, Pete, or are you using OpenStack? Is that what